Right, probably video number 5, I'm not sure. Okay, but this is a trigonometry graph, and this happens to be the cosine graph, and they've got really clear features. So when you learn what the features are, it's easy to understand. You can see that the graph at the moment is trapped between 1 and -1, and that's the same for the sine graph. And this graph actually is broken into sort of quarters for me. So there's actually a break here in my mind, and a break here, and a break at the end. So you can see it's in sections of 4. And it actually goes 90, 180, 270, and 360. And that's degrees. Okay, so we're familiar with Sokotoa. Some of us may be familiar with the graphs, completely understand where they come from. But this coordinate now means that it goes along 90 and up 0. Okay, so knowing the features of them helps with these types of ones. So I could have said, what's the value of the minimum point down here? And I could go 180 minus 1. This one is a transformation of the graph. So that graph, I'm going to have to draw it differently. It's going to have to look different. Okay, and the difference is that I've got this 2 on the left of cos. Okay, and what that means is the values of x are going to be, or the distance from the x-axis is going to be twice as far. The amplitude of this curve is going to grow to twice the length. It's still going to be cutting through at the same point, but this is actually going to start at 2. It's going to go down to -2. I'm going to go back up to 2. So the distance it travels from the x-axis has been doubled. It's been stretched out by a scale factor of 2. So I'm going to come down here, up there, and back through. Okay, so it's twice the distance. Okay, and it is a sketch. So that's what it looks like. Okay, and when you learn the trig graphs, there are certain different types of transformations. There's this stretch in this direction. There's a squash or a stretch in this direction where the curve changes. The amount of curves you actually see will double, or it'll be shallower or whatever. And MathWatch does a really good job in explaining when to know it's going to be an amplitude or a frequency thing. Okay, and that sort of relates to the physics part there. But this one is a big question. Okay, it does say simultaneous equations, but do not be convinced or tricked into thinking that it's one of the where you've got 2 equations, you have to eliminate one. Okay, just looking at people out my window, making sure I do the right thing. Welcome to a school. Right, sorry for that long pause. Right, okay, so we still have 2 letters, we still have x's and y's, and we still have to eliminate them. Okay, that's still our job. But we can't manipulate these in a way where we can do with simple ones. Okay, and the reason I know, even if I didn't have an experience, it's not the same because I've got 2 separate sets of answers, and it's out of 5, so not just out of 4 as a maximum for the other ones. So what I need to do is to understand how to eliminate one of these letters, so I can find one of them and then put them back into the equation as normal. Okay, so that's what I'm going to attempt to do. Now, for those who are experienced, it does relate to quadratic expressions. I may have to factorise, I may have to use the quadratic equation. So we will see. Okay, so what I'm going to do, it's told me that y equals x plus 6. So on this top equation here, where it says 2x squared plus y squared, I can change the y for x plus 6. So I've got 2x squared, and then instead of this y, I'm going to put x plus 6. So instead of that y there, I'll put x plus 6, and that's squared. And that equals 51. Okay, so now I'm just going to get this expanded, and I'm going to simplify and try to form a quadratic equation, because that's kind of where it goes. So I've got x plus 6, double bracket. Okay, and just change little bits at a time so you're consistent. So this 2x squared is going to stay the same for a while. I'm going to do x times this bracket and 6 times that bracket. And this is kind of why on the post it says Mr. Long-Winded, because some people will take a lot of time to do this. Hardly any time, sorry. They'll know the answer to this straight away, like this is x squared plus 12x plus 36 as it will be. But I think you need to be really rigorous with your maths and make sure you don't make any stupid mistakes. And some people, when they just assume they know the answer, can make really awful mistakes that they can avoid if they were clear like I am now. So I'm going to gather them together now. So that's going to be 3x squared plus 12x plus 36 equals 51. Now I can't solve this yet because it doesn't say equals 0. So I'm going to sort that out now by taking away 51. And so I've got 3x squared plus 12x. And then I could do it, but I'm not going to. I'm just going to do the calculator because that's what I've got it for, and that's minus 15. And equals 0. Now in the question, it doesn't say anything about rounding. It doesn't say it's either 2 decimal places or 3 significant figures. If it did, that would be a clue that I'd be using the quadratic formula. It doesn't, so it suggests to me that I can factorise this. So I'm going to try and factorise it and see what we get. So we'll do 3 times minus 15, it's minus 45. Okay, and then I'm going to do the factors. So 1 and 45. 2 doesn't work. 3 and 15. 4 don't work. 5 and 9. 6 don't work. 7 don't work. 8 don't work. 9, I've repeated myself, so I'm done. Excuse me, and that leaves these pairs, and I think I can do it because it's minus 45. Again, I want this difference of 12 because that's what's here, that's in the middle, and these have a difference here of 12, these two here, and I'm after positive 12, so I'm going to make the small one a negative. So this is going to split. 3x squared is going to come down. It's going to split into minus 3x, and put the negative first, plus 15x minus 15, and then line down the middle, factorise both sides. So 3 and x is in both sides, leaving x minus 1. And that's what I'm hoping will come out in this bracket. The x minus 1 should come out here. 15 is in both of these, and that leaves x minus 1. And now I can, now the bracket's saying I know I'm on the right track, so I can take the bracket out, and I've got this as my factorised solution. When I'm solving, x will equal 1 here. You can set little equations up, but I prefer just to do it this way. If it was x plus 15, it'd be negative 15. So let's start with negative 15. But the 3's there as well, so that has to come down and create this little fraction here. So it becomes minus 5. So at the moment, there are my 2 solutions for x. So that's why we have 2 answer boxes for x here. Then I'm going to use them to find the missing values for y. So the best thing is just to use the smaller equation here. So it could take less time really. So y equals x plus 6. I'm going to try x equals 1. So y equals 1 plus 6, which means that y equals 7. So when x is 1, y is 7. And then I'm going to do the same. So when x is minus 5, I've got y equals minus 5 add 6, which is 1. So when x is minus 5, y is 1. The same with basic simultaneous equations. If I take a pair of these answers and I put it in the top equation here, it should work. And that's a way of checking. So I'm going to do that just to make sure I've got it right. So I'm going to put x is 1 and y is 7 into this top equation, just so I walk away with some confidence. So we think x is 1 when y is 7. And we think that should equal 51. 2 times 1 squared, 1 times 1 is 1, so that's 2. 7 squared is 49, and 2 add 49 is 51, so I've definitely got it right, and then I know I can walk away with 5 marks. Okay, so when you see this, expect to be doing quadratics, expect to either solve it by factorising or by using the quadratic formula. If in doubt, you can just use the quadratic formula for any equation, especially a calculator one, because it will always work. But I just avoided doing that by factorising. But I could have literally just got the quadratic formula out, which is this. And substitute these values in, the 3, the 12 and the minus 15 is here, and it would have given me these 2 values, 1 and minus 5 as well, and it'd been absolutely fine. I just didn't because I didn't have any decimals, so I knew I wouldn't have to. Excuse me. Right, next one. ABCD is a parallelogram, which means I know that these lengths are the same. This has been cut through these 2 parallel lines, so I know that's 95. Okay, I know that's 8. I know that's going to be 12. Okay, so I know that these triangles are similar, they are the same triangles. Okay, so that's just the feature of the parallelogram. When it's been split like that, that's the same. The question doesn't want me to tell them that that's 95 because it's an alternate angle, although it is. It wants to know the area of the parallelogram. So we have to go through the process of being able to find the area of these triangles, even though we ain't got a base or a height, which means we might be using half AB sine C, which is the sine rule for the area of a triangle. But that requires you to have two sides with the angle trapped in between it. We don't have any of that. That's that picture where you've got two sides and an angle in the middle of it. We don't have that at all, so we can't use that yet. So our main objective is to get more angles in this picture, because when we've got more angles in the picture, we can use the sine rule for the triangle, area of a triangle. So that's what I'm going to do. So if I had this angle, or this angle, I could move a bit further. So let's see. So I've got this pair of angles and sides here, okay? I don't have a pair for this angle, and it'd be ideal because then I pretty much could just, if I had this angle here, I could use the sine rule because it's trapping these, this angle here is trapped by these two sides. But because it's a triangle, if I find this angle anyway, it's out of 180 degrees, so I can label it up. So I've got this angle that's missing here, so let's just call it A, doesn't matter. If I find A, I can find this angle here, then use the sine rule. The sine rule for area anyway. But this is the sine rule. This is where we're doing the two arrows to show we've got a pair of sides, a pair of angle and sides and one missing angle, but you've got the other side to it. And this is the sine rule for angle. So sine A over A equals sine B over B, which is just sine and the angle you're after. So sine A over its opposite side. So A is over 8, so that goes together. And sine B, so B is the angle you've got, so 95, over the side that it's opposite, so 12. And now we have to unpick this to make A the subject, so we have to solve A. So first of all, 8's going to move up to there. We're going to multiply by 8. That's technically what I'm doing. So sine A equals A sine 95. It was going to be our last lesson together. Obviously, I didn't get there for that lesson. We were going to do the sine rule, which is what I'm doing right now. Over 12 still. And now, just like Sokotoa, where we're finding a missing angle, we are going to remove sine from the left. Okay, so effectively we're dividing by sine, but remember that the calculator does sine to the -1, and that's how it will go in the calculator. So you just be careful with putting your calculator, entering into the calculator. So second function sine to -1. Do not put sine to the power of -1. That's not anything to do with this. This is a program thing. Fraction button, 8 sine 95 over 12. So A equals 41.6156 and so on. The answers to 3 significant figures, so I've just got to keep this bigger than that. So that's enough. That'll keep me accurate with this one. Okay. So that is this angle, and I'll keep going on and on, but I want you to be labelling up your diagrams so the examiner has no excuse when trying to look for your answers because they're clearly labelled. So now I'm going to try and find this missed angle, so let's just call it, I don't know, I'll rubbish it B, so I'm going to do M. It doesn't matter what you call it. So M is 180, take away the 95, take away our answer. Okay, so I'm just going to do that now. So 180, take away 95, take away 41.6156. So that missed angle is 43.3844 degrees. So let's put it on 43.3844. And now I can use this to use it for the sine rule for the area of this triangle. So I can find the area of this triangle now using the sine rule. So sine rule for area is a half AB sine C, where these two are the sides that trap the angle, so trapping sides, and this is the trapped angle, so trapped angle. So it's a half times by the two sides, doesn't matter which way around it is, times sine and the angle that it's trapping, so 43.3844. Okay, so that's what I've got. Remember, because it's the 3 significant figures, I'm just doing it more than that now. But that is one triangle. So for 2 triangles, I'm going to do that times by 2. Times by 2. Get 65.94140,735. And significant figures start from the front. 659. That's where it's going to be cut off. So it's going to be either this 65.9 or 66.0. So it's going to be 65.9 centimeters squared. Okay. So big question, and it's worth 5 marks. So it should be a big question. But when you break it down, it is the basic. It is quite basic in terms of the steps. If you know the sine rule and you know the sine rule for area, it's quite straightforward.